You are given the quadratic function x squared minus 5x minus 6, and you are required to sketch it, right? I'm going to take you through the steps that you need to follow that will help you draw this quadratic function. So when you're required to draw a quadratic function, it's very important to remember that a quadratic function can either be represented in a form of ax squared plus bx plus c, or in the form of f of x, which is equal to a, open bracket x plus p all squared plus q. Alright, so those are the ways that a quadratic function can be represented. So now looking at what we are given here on the board, we've got f of x, which is equal to x squared minus 5x minus 6, right? So is this in the form of f of x, which is equal to ax squared plus bx plus c, or is this quadratic function in the form of f of x, which is equal to a, open bracket a, x plus p all squared plus q? You guessed it. It's in the form of f of x, which is equal to ax squared plus bx plus c, right? So if your quadratic function is in this form, these are the steps that you need to follow to help you draw this quadratic function. The first thing that we're going to look at is the shape. The second thing that we're going to look at is our x and our y intercepts. The third thing that we're going to get is our axis of symmetry. And once we have our axis of symmetry, then we will be able to get the turning point, and we are done. We are done, right? Then we can simply draw our quadratic function. So I'm going to say that again. We're going to look at the shape of our quadratic function. We are going to look at the x and the y intercepts of our quadratic function. We are going to look at the axis of symmetry, and once we have the axis of symmetry, we will be able to determine the turning point of our quadratic function. And once we got our turning point of our quadratic function, we are done. We are just plotting, and then you get your marks, right? So let's get started. The first thing that I mentioned is the shape, right? How do you determine the shape of your quadratic function? Like I mentioned, if your quadratic function that is given is in the form of f of x, which is equal to ax squared plus bx plus c, okay? If this quadratic function that you're given is in this form, then the value of the a is going to tell you about the shape of our quadratic function. If your a is greater than 0, then your quadratic function is going to be a open upwards. And if your a is less than 0, then your quadratic function is going to open downwards. Okay, so if your a is greater than 0, it's going to open upwards, and if your a is less than 0, it's going to open downwards. Please make sure that you watch the video that I've created for you guys, where I've done an amazing summary for you guys on the quadratic function. Okay, so it's going to be like explained in detail. Okay, so we mentioned that if your a is greater than 0, your quadratic function opens upwards, and if your a is less than 0, your quadratic function opens downwards. So let's look at this equation that is given to us, right? We've got x squared minus 5x minus 6, right? So what is the value of our a? Okay, so I'm just going to write it here. Our a is equal to 1. You guys agree that there is an invisible 1 there? Okay, so your a is equal to 1, your b is equal to minus 5, and your c is equal to minus 6. C for constant, our constant value is minus 6. Our b, what is the coefficient of our x? It's that minus 5 there. And then our a, what is our coefficient of our x squared? And that is that invisible 1 there. Okay, so now that we've got that sorted out, we know that we've got our a is equal to 1. So what does that tell us? If our a is greater than 0, then that tells us that our parabola or our quadratic function is going to open upwards. So we already have one aspect of this quadratic function. Our quadratic function is going to open upwards, right? Second thing that I said we need to do when we are required to draw a quadratic function is we need to get the x and the y intercept of this quadratic function. So how do we get the x and the y intercepts? Okay, so to get the x and the y intercept of a quadratic function, we need to either let x equal to 0 or we need to let our y equal to 0. Right, let's just have a look at what we're given here. We're given the quadratic function f of x, which is equal to x squared minus 5x minus 6, right? Do you guys agree that this quadratic function can also be written like this? Yes, it can, right? Because f of x is the same as saying y, okay? So now, once we've written this quadratic equation in this form, we can start off now. We can actually start getting our x-intercept as well as our y-intercept, right? So let's get started. To get our y-intercept, what do I mean by our y-intercept? Where our quadratic function cuts the y-axis, okay? So for us to determine where our quadratic function is going to cut the y-axis, what do we need to do? For us to determine where our quadratic function is going to cut the y-axis, what do we need to do? We basically need to let our x equal to 0, right? So what we're going to do to get your y-intercepts, hopefully. Okay, so to get your y-intercepts, I hope that shows, we are going to let your x equal to 0. Okay, so if we let our x equal to 0, what are we left with? So it's going to be y, which is equal to, if we let the x equal to 0, where you see your x, you're going to put a 0. 5, 0, minus 6, okay? What are we left with, guys? We don't need a calculator for this. This and this simply cancel, and you find that your y is equal to minus 6, right? So the y-intercept of this quadratic function is at minus 6. So it is somewhere down there, right? So we've already found one point of our quadratic function. So our y-intercept is 0 and minus 6. So now that we've calculated our y-intercept of this quadratic function, we need to get the x-intercept, right? So what do I mean by the x-intercept? X-intercept is where the quadratic function is going to cut our x-axis, right? So where our quadratic function is going to cut our x-axis, right? So to get the value of our x-intercept, what do we need to do? We need to let y equal to 0. So to get our x-intercept of our quadratic function, we need to let y equal to 0. Okay, so when we let our y equal to 0, what happens? So that's going to be 0 because that's our y. You're going to be left with x squared minus 5x minus 6, right? And then you are going to simply solve this equation for x. And I'm sure you guys can see now we've got a quadratic equation, and a quadratic equation can be solved by simply using the quadratic formula or by simply factorizing it using the process of inspection, right? So let me actually start off by factorizing this quadratic equation using our process of inspection. So what do? We usually just put two brackets, right? Okay, so we've got two brackets, right? And then you put an x there, you put an x there, right? We've got a minus sign there, right? So if there's a minus sign there, you're going to put a plus and a minus, right? And then we're going to think of the factors of 6 that when I plus or minus them, right, they'll give me a minus 5. So if you take a minus 6 plus 1, minus 6 plus 1 gives us a minus 5. And then a plus 1 multiplied by a minus 6 gives us a minus 6. So we've already factorized this equation. If you don't like this method, then you can simply use the quadratic equation the quadratic formula, which is x, which is equal to minus b plus minus b squared minus 4ac all over 2a, right? And then you're going to simply substitute the value of our a, b, and c into this equation, and it will take you back to these x values that we got. Okay, so we found that the value of b is minus 5, so you're going to substitute that into the equation. We found that the value of a is 1. We found that the value of c is equal to minus 6, and we found that the value of a is equal to 1. Simply, guys, take your calculator. Okay, so I'm just going to do that quickly for you guys. Okay, so if you just substitute those values of your A, B, and C's into your calculator, that is what you're going to get. And as you can see there, I started with the positive, right? So I started by substituting the positive, and then you can just go on and substitute your negative when you're done. So when you've started with the positive value, we found that the value of our x is equal to 6, right? And then when you put in the negative value, you found that your value of your x is equal to negative 1. Okay, guys, so I'm just going to move back to what we have here in the brackets. So if you actually just solve for x, we found that your x is equal to negative 1, or your x is equal to 6, which is what we got there from using the quadratic formula, right? So you found the 2x intercepts, right? So the 2x intercepts, when your x is equal to negative 1, your y is equal to 0, or when your x is equal to 6, your y is equal to 0. Guys, can you see that we're getting somewhere? Okay, so we've already found our y-intercept, and we found that our y-intercept is negative 6, right? So when your x is equal to 0, your y is equal to negative 6. We've already found our 2x intercept, which is negative. When your x is equal to negative 1, your y is equal to 0. Or when your x is equal to 6, your y is equal to 0. And now, guys, the next step in this process is to get our axis of symmetry. So what is the axis of symmetry? So our axis of symmetry is where it's basically an imaginary line that cuts our quadratic function into two equal halves. So it's an imaginary line that cuts our quadratic function into two equal halves, right? So for example, right, if this is my quadratic function, okay, that is my axis of symmetry. Okay, this is my axis of symmetry, and the axis of symmetry is that imaginary line that cuts this quadratic function into two equal halves, right? So how do we get this axis of symmetry? This axis of symmetry is obtained by using the equation x is equal to minus b over 2a. Okay, by simply taking x, which is equal to minus b over 2a, you will be able to get that line that goes through our x-axis, that imaginary line that cuts through the x-axis and that splits our quadratic function into two equal halves, right? So let's get the axis of symmetry for this particular quadratic function. All right, so we said that to get your axis of symmetry, right, you say x is equal to minus b over 2a. Right, so it's pretty awesome that I've already written out the values of a, our b, and our c here on the side, right? So we're just simply going to substitute. We're not going to stress our lives, okay? So you've got your b. What is our b? So it's a negative. What is our b? We found that our b is negative 5. So it's minus 5 all over 2. What is our a? Our a is 1. Guys, it's important to actually include these brackets, because I also remember when I was in high school, these are like the silly mistakes that I would make, because I would forget this negative and it'll just be like a minus 5, and that just messes up your whole question. Okay, so please don't make these silly mistakes. Make sure that it's minus b, so it's a minus, and then what is our b? Our b is already a minus 5, so it's going to be minus, open bracket, minus 5. That's what you need to include there in your equation, right? So if you punch that into your calculator, what do you get? So minus and minus gives you a positive. It's a 5 over 2, right? So our axis of symmetry x is equal to 2.5. Okay, so that imaginary line that splits our quadratic function into two equal parts, right, goes through our x, which is equal to 2.5. So now, once we found the axis of symmetry, oh man, I can see the light. We are almost done, right? What do we need to do from here? We need to take this x value that we got from using the x value that we got, and you need to substitute it back into our original equation. And someone might be like, okay, how's that going to help us, right? That is going to help us get the turning point, right? So once you've got your x's of symmetry, then you can get your turning point. And how do you get your turning point? You simply take the x value that you've obtained, right, from using the axis of symmetry equation, and you substitute it back into your original equation, and that's going to give you your y value. And from there, what does that tell you? That tells us that that is our y value for the turning point of our parabola. Okay, that's the y value of our turning point of our parabola. So you're going to take this x value that we got here, which is 2.5, and you're going to substitute it back into this equation to get the y value for our turning point of our quadratic function. Let's get cracking. Okay, so we said that your x is equal to 2.5, right? So you're going to just substitute that 2.5 all squared minus 5, 2.5 minus 6. Okay, punch that into your calculator. And you'll find that you get a y value that is equal to negative 12.25. Okay, so this tells us that the turning point of this quadratic function is 2.5, is when our x is equal to 2.5, and when our y is equal to negative 12.25. Guys, we are actually done. All that's left for us to do is to just sketch this quadratic function, right? So I'm just going to write down all the values that we've basically calculated. When you're required to draw a quadratic function, right? Okay, and your quadratic function is in the form of y, which is equal to, or f of x, which is equal to ax squared plus bx plus c, right? When you're required to draw that quadratic function, you need to first think of the shape, right? What is the shape going to look like? And when I talk about the shape, I'm saying, is the quadratic function going to open upwards, or is the quadratic function going to open downwards, right? And if your a value is greater than 0, that tells us that your quadratic function is going to open upwards. And if your a value is less than 0, that tells us that a quadratic function is going to open downwards, right? From this quadratic function that we were given, we saw that our a value was greater than 0, right? And because it's greater than 0, that tells us that our quadratic function is going to open upwards. So the one was the shape, and we found that your a value was greater than 0, and because our a value is greater than 0, we know that our quadratic function is going to open upwards, right? Second thing that you need to look at, or you need to find, you need to get the x and the y intercepts, right? I'm just going to write the intercepts, right? So you find your intercepts by letting your x equal to 0 or by letting your y equal to 0. Right, and we found that your x, when you let your x equal to 0, we found that the y, the coordinates of our y-intercept was 0 and negative 6, and we found that when you let your y equal to 0, our coordinates of our x-intercept were equal to, I think it was negative 6 and 0, as well as actually positive 6 and 0 and negative 1 and 0, right? And the third thing that I said that you need to do is you need to get your axes of symmetry, right? So I said that the axis of symmetry is that imaginary line that cuts your quadratic function into two equal halves, right? And you find the axis of symmetry by using the equation x, which is equal to minus b over 2a, right? And we found that our axis of symmetry for this quadratic function was x, which is equal to 2.5. And once you found your axis of symmetry, you can get the turning point of this quadratic function. And how do you get the turning point of your quadratic function? You simply just take the x value that you obtained from getting the axis of symmetry, and you substitute it back into your original equation. And by substituting that back into our original equation, we found that the turning point of our quadratic function is 2.5 and negative 12.25. Okay, and then from here, guys, it is simply easy to sketch your quadratic function because we've got our shape, we've got your intercepts, your x and the y intercepts, you've got your axis of symmetry, and you've also have your turning point. You simply just sketch and you are done. Okay, I hope you guys enjoyed this video tutorial. Please make sure that you like and comment and just tell me how you found the video. Did I make it easy for you to understand? Did you enjoy the video? And please guys, make sure that you subscribe to the channel. I know that there's a few of you guys that are like really watching my channel without subscribing. So if you really enjoy the mathematics content, please make sure that you subscribe to the channel. There's more awesome videos, mathematics videos, video tutorials that I will be uploading on Distance Learning with Lee. And then that is it, guys, and I'll see you guys on my next video tutorial.